Let's take a quick look at some basic trig identities. Let me warn you from now, if you need to pause this video to write anything down or anything like that, feel free to pause and write and think, because I'm going to be going through this very quickly. Trig identities in math, an identity is an equation which is always true. It can be trivially true, like x equals x, or it could be usefully true, just like how we use Pythagorean's theorem, a squared plus b squared equals c squared, the right triangle. Trig identities are equations that involve trig functions, and there are loads of trig identities, but we're only going to look at a few of them. I'm going to break it down into 4 groups for right now. So we have the basic identities, which is tan equals sine over cosine, and cotangent equals cosine over sine. Let's take a look at why this is true. If I take the sine function, which is y over r, and I divide that by the cosine function, which is x over r, what happens is I get y over r times r over x. Now when the r's cancel, we end up with y over x. Now from our memory, what is y over x? Well, y over x is tan theta. And so for that reason, sine over cosine is the same thing as saying tan theta. Of course, if you do the reciprocal of that, we already know that the reciprocal of tan is cotangent. So if sine over cosine is tan, then you know that cosine over sine is cotangent. Now we also have the reciprocal identities, which we can kind of already have a foundation for. We know that sine and cosecant are reciprocal, so it makes sense that sine theta is equal to 1 over cosecant theta, and it makes sense that cosecant theta is equal to 1 over sine theta. They're reciprocals. That's what reciprocal means. Now before I show you the next group of identities, which is the Pythagorean identities, I want to show you what squared trig functions look like. When we multiply sine x times sine x, we do not want to put sine x squared with no parentheses or anything like that. This will confuse us because we don't know if you're squaring the whole thing or if you're just squaring x. So mathematically, if you see that written down, people are going to assume that you're squaring just the x. So instead, sine times sine is going to be sine squared x. Cosine x times cosine x is going to be cosine squared x. And this is true for all 6 trig functions. You put the squared between the trig function and the variable. Alright, and all this really means is when you see a sine squared x, it means sine x times sine x. Or if you want to put the parentheses, you can say sine x in parentheses squared. So now let's take a look at the Pythagorean identities. We have sine squared theta plus cosine squared theta equals 1. Now let's prove this for a second. What is sine theta? Well, sine theta is y over r. And if I square that, that's y squared over r squared. And then cosine squared theta would be x over r, but squared. And so you'd end up with x squared over r squared. Now we have the same denominator, so we can add these. So we end up with y squared plus x squared over r squared. Now, we already know from prior knowledge that y squared plus x squared is equal to r squared. So what you end up with is r squared over r squared, which is 1. So that's a nice to know and a need to know. You don't need to prove this, but just in case you're wondering how these squared equals 1, that's the reason why. The main thing I want you to pull from this is that if I have sine squared theta plus cosine squared theta equals 1, I can use this 2 different ways. I can solve for sine squared, and then I'll realize that sine squared theta is equal to 1 minus cosine squared theta. Or I could solve for cosine squared theta, in which case cosine squared theta is equal to 1 minus sine squared theta. And this is very useful when you are given sine and you need to find cosine, or if you're given cosine and you need to find sine. So if you have one, you can get the other. The same is true for the next two Pythagorean identities. Tan squared theta plus 1 equals secant squared theta. So if I'm trying to find secant squared theta, I'd use that. If I'm trying to find tan squared theta, all I'd have to do is minus 1 on both sides. And I will get tan squared theta equals secant squared theta minus 1. Cotangent squared theta and secant squared theta are related to each other. If I'm trying to find cosecant, I can leave it as is. If I'm trying to find cotangent using cosecant, all I have to do is minus 1 on both sides. I end up with cotangent squared theta is equal to cosecant squared theta minus 1. Now we have the even odd identities. We've been kind of playing around with this. We've looked at the parent functions, and we've looked at the graphs, and we've identified which ones are odd and even. Now we're going to use it as an identity. Basically, any even function that you have, for example, x squared, if I put it through that function, so if I take the square of negative 1, for example, negative 1 squared is equal to positive 1. Basically, the negative goes away. If I do that with an odd function like x cubed, if I do negative 1 cubed, well, cubing it will not get rid of the negative. Negative will just go on the outside. So basically, with the even and odd functions, the main thing we need to remember is that of the basic 3 trig functions, the even one is cosine. The other 2 are odd. What this means is if I take sine of a negative angle, that is the same thing as putting the negative on the outside and taking sine of a positive version of that angle. So basically, that negative is brought to the outside. For cosine, which is an even identity, that negative gets cancelled. So it doesn't matter if it's negative or positive, you get the same answer. As far as the reciprocals go, they follow the same suit. Secant is the reciprocal of cosine, which is also an even function. All the rest are odd. So here we have all 4 sets of identities that we're covering today. I need you to pause the video. I need you to write all of these identities down. And although you have them on your person, it will be a great idea to memorize these identities. This will help you a lot when you're actually doing the problem, and if you already have all of these identities in your mind, it'll make it a lot easier to figure out what you need to do first. So here's our first example. We have sine theta equals 3 over 5, and theta is between 0 and 90 degrees. They want us to find cosine and tangent. Whenever you encounter these problems, you need to keep in mind that that first part that they give you, that tells you what a trig ratio is, that's going to get you your value. That second part that they give you, it's either going to tell you what the angle is, or it's going to tell you whether another trig function is positive or negative. That second portion is going to tell you which quadrant it's in. And the reason why you want to know what quadrant it is because depending on the quadrant, your answer will be positive or negative. So I usually break it down into 2 sections. I find the value first, and then I use that second bit of information to find if it's positive or negative. Now, if you recall, we have all these identities to use. Which of these identities relates sine and cosine? Remember we talked about if I have sine, I can find cosine. Which of these identities does that? Well, if you look down here, the Pythagorean identity, we have sine squared theta plus cosine squared theta equals 1. Which means if I have sine theta, I can rearrange that to get cosine theta, because that will be my only other unknown. Also, once I find cosine theta, if I have sine theta and cosine theta, how can I relate that to tan? Well, if you look at your basic identities, if I have sine and cosine, I just need to divide them to get tan. So let's use these two. Since I'm trying to find cosine theta, we're going to rearrange this and say cosine theta is equal to 1 minus sine theta. Cosine squared theta is equal to 1 minus, and we're going to square what we have for sine theta. 3 over 5 squared. So that gives me 9 over 25. And 1 is the same thing as saying 25 over 25. So if I change the 1 to 25 over 25, minus 9 is 16. And then to get my answer, I will have to take the square root, because the 16 over 25 represents cosine squared theta, not just cosine. So we find the square root of that to get cosine by itself. So we have cosine theta is equal to 4 over 5. Now that's the value. Whether it's positive or negative is going to depend on the quadrant. Our theta is between 0 and 90, which means we're in the first quadrant, which makes this positive. Alright, let's finish up this question now. We need to get tan, which is sine over cosine. Sine is 3 over 5. Cosine is 4 over 5. The 5's cancel, and we get 3 over 4. Now again, we're in the first quadrant, which makes this a positive 3 over 4, and that will be my answers. Alright, so we have another group. It says find the value of each expression using the given information. Let's take a look at these first 4 really quick. Now we have cotangent theta equals 12 over 5, find tan theta. Now what I know about this is that cotangent and tan are reciprocals. If I can look at that and already have in my mind, if I already have this memorized, then it's easy for me to say, I know they're reciprocals, all I have to do is flip it. Now the same is true for secant and cosine, for tan and cotangent, and for sine and cosecant. So if I already know this, then this is a very quick problem. Tan theta is going to be 5 over 12. Cosine beta, that b is a beta, is going to be the reciprocal of negative 2, which is negative 1/2. Cotangent is the reciprocal of tan, so that's going to be 3 over 2. And cosecant is the reciprocal of sine, so that's going to be negative 4. Really quick, really easy.